Hello everyone and welcome back to exercise number 51 of the SolidWorks basic tutorial series. In this video, we're going to be designing a flanged shaft support. As always, designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature, but also in creating this top flange, we're going to have to create a new drawing plane, which is something, of course, if you've been following my videos, you'll be able to do very easily. Here we see the schematic drawing for exercise number 51. All dimensions are in millimeters. If you zoom in closely, the unit system is set to millimeters, grams, and seconds. We have the isometric view, we have a section view, and the section view showcases the hollow opening here for the component. We have the top view, the front view, and the right view. Of course, we also have a set of instructions which are, needless to say, pretty self-explanatory, but the key takeaway is that at the end of the modeling process, we need to assign a material of alloy steel, okay? And of course, we have a question here at the bottom that says, what is the mass of this part in grams? And of course, the answer should be given within a tolerance of plus or minus 1 gram. All right, so we're going to follow a feature-driven approach in creating this component. And the obvious first step would be to create the square base flange, which involves, of course, using the center rectangle tool, and then using the fillet tool to round out the four corners of the square. And then, of course, we're going to use the extrude boss base tool to create thickness. After that, we're going to work on creating the cylinders. They have the top cylinder and the bottom cylinder. If we look at the section view, we should clearly see that we have a bottom cylinder. So again, we're going to use the circle tool, and then you use the extrude boss base tool. After that, we're actually going to create the four mounting holes for the square base flange. These are four counterbore holes. So we're going to either use the hole wizard tool, or the more intuitive approach would be to use the extrude cut tool, all right? And we're going to use it twice. First, to create the first cut for the larger circle, and then the cut for the smaller circle. After that, we're going to create the top flange. Of course, this top flange, we have to create a new drawing plane, and the drawing plane needs to be 13 millimeters away from relative to the top of the cylinder. So that's a pretty simple procedure. And then we're going to sketch out the 2D profile of the top flange using a number of tools. Most importantly, we have the circle tool, and in addition, of course, the line tool and the rectangle tool, which of course is a very simple procedure. Finally, we're going to open up the component along the y-axis. So we're going to sketch out the half of the opening here, the 2D sketch represented by the hidden line, and then use the revolve cut tool. And that would conclude the modeling process. Of course, finally, we have, we shouldn't forget that we have a chamfer here at the bottom. And if we look at the right view, we have a chamfer that is 5 millimeters by 45 degrees. That is the convention we're going to be following for the chamfer, a distance angle convention. All right, so this is a very simple exercise, something to have fun with. All right, so with that aside, let's get started with exercise number 51. Okay, so let's start by creating a new SolidWorks part. Let's set the background to plain white, and let's copy exercise number 51 into SolidWorks. Let's go ahead and make this smaller, and then drag it upwards. All right, so as I said previously, the first step would be to create the square base flange of the component. So to start, let's go ahead and select the top plane, sketch. Let's drag this to the side, and starting from the origin, let's use the center rectangle tool to create a rectangle. All right. Now, if we look at the top view, we see that for this square base flange, we see that we have a dimension of 76 millimeters. And we have a symbol here that looks like a square. Basically, what it's telling us is that the length of this edge and the opposite edge here are equal, because it's a square, obviously. So let's activate the Smart Dimension tool and set this as 76 millimeters. Let's go ahead and click on this entity, and holding down the Control key, click on this entity as well. And let's set the relation as equal. All right. So now this edge here has a dimension of 76 millimeters, similar to what we created for this line. All right, so also, if we look closely, we have fillets or rounded out edges for this square base flange, and we have a fillet radius of 12 millimeters. So let's go ahead and select the fillet tool, set the fillet radius to 12 millimeters, and then go ahead and select 4 corners of the square. 2, 3, and 4. All right, and then click OK. So now we have the 2D sketch for the square base flange. Now just very simply press the S key and then click on Extrude Boss Base. All right, and if we look at the side view here, we see that the base flange has a thickness of 10 millimeters. So by default, it's already set to 10. Simply just click on OK. All right, so that creates the square base flange of the component. If we look closely here at the section view, we see that we have a cylinder protruding from the bottom face. All right, and this cylinder has an offset diameter of 46 millimeters, similar to the cylinder here at the top, and it's protruding from the bottom with a thickness of 7 millimeters. So what we're going to do is simply click on this back face, or bottom face, click on Sketch, activate the Circle tool, and from the origin, draw a circle. Activate the Smart Dimension tool. The diameter of this circle should be 46 millimeters. Now, very simply, press the S key, Extrude Boss Base, and set the extrusion at height of 7 millimeters, and then click OK. So that creates the bottom cylinder, the protrusion at the bottom. All right, so we're going to perform a similar process for the cylinder at the top. So just click on this top face, Sketch, activate the Circle tool. From the origin, draw a circle, Smart Dimension. This should have a diameter of 46. Press the S key, Extrude Boss Base. All right, so the question is, how high should the extrusion should be? If we look closely here, we have a dimension of 30, right? 7 plus 13, that gives us a total height of 50, right? So this needs to be 50 millimeters. Click on OK. All right, so that creates the cylinder at the top. Now, if we look closely, we have a number of mounting holes for the square base flange. So let's go ahead and create that. But need to notice also that these are counterbore holes, not normal holes. They are counterbore holes. So we're actually dealing with 2 dimensions. We have the dimension of the larger circle with a dimension of 14 millimeters and the diameter of the smaller circle of 10 millimeters. So let's just go ahead and create the first sketch. So from this surface, Sketch, activate the Circle tool, and from these centers right here, we have 1, 2, 3, and 4. Activate the Smart Dimension tool, and we have a diameter of 14 millimeters for one of the circles. Just click on the rest of the circles, holding down the Control key, selecting all 4 circles, and set the relation as equal. Okay, so automatically the dimensions for these 3 remaining holes will be 14 as well. So now just press the S key, Extrude Cut, and we're going to cut this sketch to a thickness of 3 millimeters, sorry. So set the extrusion cut to 3 millimeters, and then click OK. All right, now just click on this surface, Sketch, zoom in, activate the Circle tool, and from the center here, draw a circle. We're going to do the same thing for the rest of the circles here. 1, 2, 3, and 4. All right. Activate the Smart Dimension tool. Let's set the diameter as 10 millimeters. We're going to select the remaining circles, holding down the Control key. Set the relation as equal. Now just press the S key, Extrude Cut. Right-click on your mouse and set the relation as up to next, okay? And then click OK. So that creates the 4 mounting holes for the base flange here, the square base flange. All right, so what other features do we have? We have a flange here, top flange, but basically the flange is not situated on the top of the cylinder. It's actually at a distance from the top. Specifically, if we look at the side view, it's actually 13 millimeters away from the top of the cylinder. So what we have to do actually is create a new drawing plane. So let's go ahead and go to Features, Reference Geometry, and then go ahead and select Plane. All right. All right, so here's going to ask us for the first reference. Go ahead and select this top face, flip offset in the opposite direction, and then set the offset distance to 13 millimeters. All right, and then click OK. So now we have a new drawing plane that is exactly 13 millimeters away from this top face here, top of the cylinder. All right, so now just right-click on this new drawing plane, sketch, and what we're going to do is we're going to sketch out the 2D profile for this top flange. So starting from the origin, let's draw a circle. That's one circle. And then let's go ahead and select midpoint line, and this needs to be directly situated relative to the origin. Let's draw a vertical line here. All right. So now let's go ahead and assign the dimensions. We have the dimension of this larger circle here, the radius of 30 millimeters. So automatically it's going to be a diameter of 60. So this should be 60. All right. And if we look closely here, the length of this edge to the side is 20 millimeters. So this needs to be 20. Set the relation between the center of this circle, this line, and this origin point as horizontal. All right, activate the Smart Dimension tool again. And if we look closely at the top view, we see that from one end of the flange to the next, it's 124. All right, so starting from the origin all the way to this edge, it should be 124 divided by 2, since we have symmetry. All right, so now what we need to do is activate the line tool and just close off the sketch using 2 tangent lines. So that this is 1 and this is 2. Just make sure that you have a tangency relation here activated for the 2 lines, okay? Now what we need to do, we see very clearly that sketch is fully defined. We just need to copy these lines to the other side. So go ahead and first of all draw a mirror line all the way, a vertical mirror line to the bottom. Activate the Mirror Entities tool. Go ahead and select these lines, 1, 2, and 3. Mirror about this vertical line, and then click OK. Now simply just trim away any extra entities. We have this and this. Go ahead and select this outer circle, and then click on Convert Entities. Right, so that would create a perfect representation for the 2D sketch of the top flange. All right, so now just press the S key, extrude boss base. And actually what we're going to do, we're going to extrude this downwards. So let's flip the direction here. And we're going to extrude this to a thickness of 7 millimeters. We see that the thickness should be 7. So enter a thickness of 7, and then click OK. All right. We don't need this plane anymore, so let's go ahead and right-click here and then hide. Are we done with the flange? No, we actually have a notch on either ends of the flange that are 13 millimeters by 6 millimeters, all right? So the strategy here is to select this space, sketch, activate the center rectangle tool, and from this point right here, let's draw a rectangle. Smart Dimension, length of this edge should be 6 millimeters. The distance from this edge to this edge should be 13. All right. Now just very simply press the S key, extrude cut. The end condition is already set to up to next, and then click OK. So that creates the notch for one of the sides of the flange. We just need to copy this to the other side. So we're going to use the mirror tool. So now we're just going to select a reference plane. So go ahead and select the right plane. For the features to mirror, select the last operation that you just performed. And then click OK. All right, so that completes the top flange. Now we just have one last thing to do. If we look at the section view, we actually have an opening. This is a hollow solid with, it's not filled out. It's actually hollow. So what we need to do, is just click on the front plane, sketch, and let's activate the line tool. And from the bottom here, all the way to the top, let's draw a vertical line. All right, so then we're just going to sketch out the opening here. If we look closely at the right view, we see that we have this opening. So we're going to sketch out half of this opening here, and then use the revolve cut tool to create the opening. All right, all the way to, let's do this again, all the way to the bottom. All right, and then just move this sideways. Okay, now let's activate the Smart Dimension tool. We see that the opening, the top hole here, has a diameter of 38 millimeters. So this needs to be 38 divided by 2. All right, and the diameter of the smaller hole here should be 32. So this should be 32 divided by 2, which is 16. All right. Is there anything else we have to do? We actually, the sketch here is fully defined. We can see that the length of this edge here corresponds to the length of this cylinders, which is 13. So I think everything's ready. So very simply, just press the S key, select Revolve Cut. Here is going to ask us for the axis of revolution. Select this vertical line, and then click OK. All right. Are we done? No, we're not done. We actually have one last thing to do. There's a chamfer here at the bottom. And if we look at the side view right here, the right view, we have a chamfer that is 5 millimeters by 45 degrees. So that is the convention system we're going to follow. We have the distance and angle convention. All right. So select chamfer here. Set the chamfer distance as 5 millimeters. And then go ahead and select this bottom edge. All right, and then click OK. All right, so that completes the modeling process. We need to assign a material now. So just right click here, edit material. The material that we're going to use is alloy steel. Apply, close. All right, so let's delete this image. If you want, you can actually color this. So go to appearance. It's not going to affect the final answer here or determining the mass of the component. So let's go ahead and select a nice blue color. Click OK. We have certain edges or faces that are going to remain metallic in color or in appearance. So just very simply select these edges or surfaces. Again, it's up to you. This is an artistic step. It's unnecessary, but I like to keep things looking good. Okay, you have this edge, and let's just go ahead and go to appearance again. Select grayscale, and let's just select a nice gray color. And then click OK. All right. So now everything's ready. Let's just go to Evaluate, Mass Properties. And if we look closely here, we have a final answer of 854.95. 854.95. If you want to round things up, it could be 855. 855. So that is our final answer. All right, so that concludes exercise number 51. I hope you all enjoyed this video. If you have any comments or questions, please leave them down in the comment section below. I'll see you all in exercise number 52. Until we meet again, bye-bye.